I'm live. That's good to know because we're dealing with things that are no longer live, which are dinosaurs. These are not live. These are borrowed from the kindergarten room. So obviously, I'm going to wash my hands after I'm done working with these dinosaurs. We've also established that in a battle between a kindergartner and a velociraptor, the kindergartner tends to win. Okay, good. Today, we're going to learn about this button on your calculator that you never understood before. Look, exclamation mark. But really, it's more appropriately this exclamation mark, but exclamation mark sounds a little bit cooler. Exclamation mark is what we really start to use a lot more when we get into the permutations and combinations a little bit more. So permutations, you're selecting things. You've got a certain number of things to choose from, and you're going to choose a few of those. Order matters. Ask anybody from Germany. Order matters in this case, okay? So here we go. I have 6 dinosaurs here. I've made over 20 kindergartners cry today by taking the dinosaur bucket. I have 6 of them, and I'm going to order them from favorite to least favorite, or something like that. Okay. Anyway, it's random because I love dinosaurs like children, so there's no real, I don't really have a preference here. So for position 1, the first most favorite dinosaur, there are 6 possibilities. Okay. So I'm going to pick this Ankylosaurus. Good. And then that's the last one I'm going to do because it's going to take too much time. Position 2, there are 5 choices. So I'm just using my multiplication principle here. For position 3, there are 4 choices. And as you can see, there we go. I have ordered these dinosaurs from favorite to least favorite. And it's 6 times 5 times 4 times 3 times 2 times 1. You have this button on your calculator. And it might look like this. Exclamation mark. I think usually it does. This is also referred to as, oh, what do I do? This is 6 factorial. So that little exclamation mark means factorial. Okay. That's how we express it. And it's good for understanding permutations, in this case, where we have selection from a limited group without replacement. Just like the dinosaurs. They've never been replaced ever since that big meteor. I said meteor, not meat eater. You'll notice that. Okay. Just to keep things clear. Now, there's a second thing, the NPR. Some of you will be lucky enough to have this NPR button, and I'm going to show you how it works. There are 2 ways to think about it. If you've got an NPR button, you don't have to think about it, but you need to understand how it works. All right. The dinosaurs have brought together a grand council, and they need to choose 3 dinosaurs for president, vice president, and secretary of state. Sorry, couldn't come up with a dinosaur double entendre there. Okay, so here we go. So choose 3 of 6. And order matters in this case because somebody's going to be number 1 dinosaur, number 2 dinosaur, number 3 dinosaur. 6 choices for president dinosaur. 5 choices for vice president dinosaur and 4 choices for secretary of state dinosaur. Okay. Now, this we don't have a factorial notation for. You could just think about it this way. But here is a second way to think about it, and this is where this NPR button comes in. This is also equal to 6 times 5 times 4 times 3 times 2 times 1, just as if we were picking 6 positions. Ooh, that's an ugly underline. My apologies. Divided by 3 times 2 times 1. Okay, and those are going to cancel out. So in other words, this is 6 factorial over 3 factorial. And so this is your NPR button. Selecting from N objects, with R permutations, selecting R things from N objects, okay? So in other words, this is, you have 6 objects to select from, and you are going to pick 3 of them, and order matters. So this is what NPR means, okay? If I'd had 12 objects and I needed to select 7, okay, it would look like this. So how many permutations of 7 objects chosen from 12 could I get, where order matters? Now the last thing is sometimes, it's usually a book problem. So the question sounds like this. So you have 12 books. You have 12 books to choose from. And you need to keep the 3 math books together. Okay, so this is a little problem that crops up again and again. They ask it in many different ways. You need to keep 3 math books together. How many ways? Can you arrange those books? Okay, so for when this crops up, this is what you do. Ordinarily, if I was just arranging 12 books, it would just be 12 factorial, and that seems simple enough. Unfortunately, we have to keep the 3 math books together on the shelf because they're the most important, okay? So really, basically, here's what we're doing. This is like as if we have 9 non-math books plus, this is the way we're going to treat it, 1 single place for the other math books, okay? So this is kind of like having 10 factorial ways to arrange those books. 9 ways to arrange all the non-math books and 1 more way to arrange the math book. So that's easy, 10 factorial, but you're not done. Because we can arrange those 3 math books, even though they're together, we can arrange them in however many orders are available to us, which is 3 factorial, okay? So you have to keep the 3 math books together. There are 6 ways, or 3 factorial ways to organize those math books. There are 9 groupings altogether. Sorry, 10 groupings altogether. 9 of them are books, and 1 of them is a math book. And so this is the formula for that. I don't know how much that is. It's big, but that doesn't matter. Okay, that's it. That's factorials, exclamation mark, or n factorial, as well as NPR, which is the number of permutations of R objects taken from a total population of n. Have to end the stream now and take the dinosaur bucket back. Oh, and wash my hands.